Right. On behalf of SAIA Practice, welcome to SAIA members, to the friends of SAIAshare, and those who have joined us for the first time this afternoon. Do remember, the event is held on the first Friday of every month. My name is Eugene Barnard. I will be your host. I trust you will enjoy the afternoon with us. Welcome again, Corina Gibson from ECPD. Corina, thank you once again for keeping the wheels rolling. We would also like to welcome Emil Paulsen this afternoon. Emil is the new SAIA Interim Executive for Practice, CPD and Education, and will be operating from the SAIA offices on your behalf. We have two power pack presentations today to equip and inspire you. Please participate by posting questions or comments in the questions box. In session 2, Gerald Stein will be discussing Le Corbusier's regionalism, to some a contradiction in terms. But first, for session 1, it is my privilege to introduce you to Francois Norquier. Francois has been practicing architecture since 1989. He is a director of Osmond Lang Architects and serves SAIA on the National Practice Committee. He has worked on large stadium projects for the City of Cape Town, the Western Province Rugby Football Union, and a World Cup cricket tournament stadium in the West Indies. He has designed and documented 8 public buildings in Trinidad and Tobago for the government of Trinidad. He has, over the years, acquired substantial experience in mass timber structures. We are privileged and grateful that he is available to share his knowledge and expertise with us. Francois, welcome, and over to you.
Eugene, thank you for the introduction, and good afternoon, everyone. It's a pleasure to be with you and talk to you about this new development in our industry. So let's get straight into it and start fairly simplistically. This talk is an introduction to CLT for persons who are not familiar with it. The slides have lots of, let's call it bonus information that you can go back to later and study in more detail. And the general slant in this industry is to do with global warming and the green industry. As we all know, the time that we live in and what we do as humans and how we exploit the resources on Earth currently determines the world of our next generation. We have to ensure that there is suitable resources left on the planet for them to live on. And by addressing global warming that is caused especially by CO2 emissions, we can ensure that future. Various global warming studies are underway worldwide, such as that of Germany's Potsdam Institute for Climate Impact Research. This institute determined that 37 billion tons of CO2 was pumped into the atmosphere since the Industrial Revolution, and the building industry is responsible for more than 1/3 of it. This was the measurement in 2018. Hence, the change in climate that is evident worldwide and the international drive towards zero carbon buildings. These studies also postulated that should 90% of future buildings be made from timber, 20 billion tons of carbon will be kept out of the atmosphere over the next 30 years. Timber buildings act like a carbon store and can achieve a zero carbon rating for a building much more readily than steel and concrete buildings. These buildings cannot reach zero carbon status in itself and relies on carbon offset schemes elsewhere to improve its rating. So if the industry keeps on producing buildings such as these depicted here, that is, carry on with business as usual, the building industry's lack of attention to global warming would amount to sheer ignorance. So what building sites should look like in future is this: a fairly new way of building with wood, where the walls, floors and roofs are all wood. This is a construction method that will make a meaningful impact on curbing global warming. So we're going to explore this in the next few minutes. The reason that this works is quite simple. Trees sequester carbon through photosynthesis and use it as building material for its structure. 50% of wood is carbon. And those of us with carbon fiber frame bicycles will know that using carbon in the structural mix makes for a very light and strong material. In the example building depicted on the right, 300 tons of CO2 was saved compared to had it been a concrete or steel construction. Due to the excellent thermal insulation of wood, it will also take 21 years for the energy requirement to run this building to release the same volume of carbon. In a sense, then, that is the carbon neutral lifespan of the building. To conclude on the sustainability aspects, timber construction addresses the United Nations Global Sustainability Development Goals, promotes development of our forestry industry, creates a new material production industry, and offers wonderful buildings to occupy. It is safe to work with, saves on foundation costs, is 30% faster to build with, and offers a crisply accurate structure. It also streamlines the architectural to production process, as 3D modeled drawings converts directly to the panel and cutting software when applying building integrated modeling or BIM principles. The table at the bottom indicates in the third and fourth column the comparison in CO2 equivalent per square meter released by buildings made of reinforced concrete versus CLT. And you can see the CLT, which we'll get to just now, is less than half of that of a concrete and reinforced concrete building. The use of timber in buildings in South Africa is not entirely new. The laminated beam industry has been around for decades, as has knotty pine ceilings and shiplap-clad timber frame beach houses. So general skills to work with timber exists, and the adoption of a new timber technology is therefore quite plausible. However, we are talking about a new product now that is called cross-laminated timber, which forms one component of mass timber constructed buildings. CLT sheets are made up by gluing timber planks together in 90-degree opposing directions for each layer to form sheets. The sheets are screwed together on site to form the cellular structures that encloses space. Floors, walls, soffit, and roofs are all made of the same product. It started in Austria in the early 90s with a PhD by Gerhard Schinkhofer that was put into practice and has since spread across Europe, America, and Australia. South Africa has a manufacturer in a company in Cape Town called XLAM, and another one is opening soon in Atlantis. Universities such as University of Stellenbosch in Pretoria are researching this material extensively. The government has taken note, and the Department of Trade and Industry is sponsoring training and other initiatives. The South African Sawmilling Association is also on board. It is an open and democratic new industry starting up, and anyone with any applicable skill is welcome. So then there are also Novotop, which is a Czech Republic company who exports the product worldwide and also to South Africa. So we can take a quick look, which will give you a quick idea as to what this product looks like whilst it's being erected. Okay, on to more technical aspects. CLT is a multi-layered engineered wood panel. There are different methods of adhesion, such as layers simply glued together under pressure, or glued and doweled, or nailed. Further variations exist, as you can see on the right-hand side there, but these are not available in South Africa as yet. Standard CLT and glulam beams are made in South Africa, and is totally sufficient technology for the current developing local market of low-rise timber buildings. Internationally, the trend is, however, to build taller buildings after the International Code Council accepted a classification system for these structures. The system puts it into different fire risk categories depending on the occupancy and escape rationale. Initially, buildings only had a rationale that worked up to 8 stories, but subsequent development now puts it at 18 stories. Much taller structures are also being planned worldwide, like the one you see there in London. So, having spoken the word fire, let's move on to fire. Extensive studies have been undertaken abroad, and the findings all conclude that a 60-minute and up to 120-minute safe building is achievable using CLT. The solution lies in working with the charring rate of the timber. The char layer that forms on the surface during fire protects the inner layers up to a point in time. The same principle as intumescent paint that carbonizes and protects a steel structure that it was applied on. So to achieve the time required for stability and integrity, extra sacrificial layers of timber is added. The thickness needed is determined by the expected fire load and resultant time to burn through. X-rated gypsum board cladding is also used as an alternative or in combination with timber sacrificial layers. And seeing that we are into immediate questions that you might have already had coming up in your mind, let's talk about cost. In a University of Stellenbosch study that you see on the right-hand side there, comparing a concrete building to CLT in South African conditions, it was found to be only 10% more expensive, taking all aspects into account, especially the speed of construction. Following on the Gantt chart at the bottom, time is saved as foundation structures are simpler and mass timber erection is generally faster. Panels are pre-manufactured off-site, and the envelope enclosure milestone is thus reached much earlier in the program for finishes to start. Timber is also most often left as the final finish inside. Services are fully pre-planned and coordinated in the BIM model and is then a plug-and-play situation on site. Generally, a 30% overall time saving is usually achieved compared to conventional construction. Timber is available in South Africa, and due to low demand for lumber products, it is presently also being exported as wood chips. The table on the top right-hand side was prepared by University of Stellenbosch and shows availability is immediate in large volumes, amounting to millions of cubes per year. And for the longer term, more forestation will be required. A promising upward demand curve will trigger this with the Department of Forestry, who are keeping an eye on this industry's development, as this also obviously makes sense from a job creation point of view as the sustainable industry is grown further. South Africa adopted their own standard for CLT manufacture in 2020, and this, together with a good design rationale, enables local authorities to approve CLT plans. The current two-story limitation of the National Building Regulations will, however, have to be overcome. South Africa's National Building Regulation Act dates back to 1977 and has not been keeping track with new developments in the international building industry. An update to the regulations are proposed to deal with new technologies that are already SABS approved and enable approval processes. And this would at the same time also resolve the countrywide backlog of approvals that are hampering development. In the meantime, similar to what the fire engineers are doing, the local authorities can be convinced to use international and apply international codes in approval processes. When looking at what is done overseas, 18-story structures are quite common. These buildings were initially designed, like the one on the right, with concrete plinths and lift shafts for lateral stability, but these are now also timber structures in later versions. The other question, of course, is timber rots. So wood preservation is an obvious concern. The first line of defense is to design the structure to stay dry or to dry out rapidly, especially at the lower levels. External facades are typically clad with a waterproof material of the architect's choice, in addition to preservation. Universities are undertaking studies in the use of different preservatives with South African wood. For CLT, SA pine and eucalyptus is most commonly used. A community of enthusiasts about wood construction has sprung up in South Africa. You can see the names on the left of organizations who are getting involved. A lot of collaboration is organized also by the South African Sawmill Association, who invites all interested parties to webinars that addresses various related topics. The next one is on the topic of fire and is on the 27th of October from 1 to 2. And if you're interested to attend, right in the middle there is the lady to contact to get you on the webinar. That is for free. The adoption of CLT will be enhanced through various interested parties attending courses and training on different aspects from design to construction. There is also talk in the industry of getting a private sector-led organization going for information sharing, ensuring standards are met, and to promote learning. This would be similar to the Concrete Masonry Association, or AMSA, in the aluminium window and door industry. So how do we as architects learn how to design CLT buildings from concept to assembly? Publications internationally are free and plentiful. An open source community exists worldwide that you as an architect can tap into. Courses are presented by overseas suppliers, and one of our architects, Carla Jooste, attended such a course in the Czech Republic a few years ago. XLAM, the local manufacturer, also gives advice at their factory and also has a drafting office to assist with drafting more than just doing shop drawings. And of course, learn like an architect. Be curious, absorb and figure it out using the architect's brain. So, where in South Africa can an architect go and have a look at such a structure? Novotop, the importer, built a show house in Hout Bay in Cape Town. And Earthworld Architects practice from Gauteng. It's also busy with mass timber structures for the University of Pretoria Future Africa campus. So let's take a look at a video of the Hout Bay house. Osman Lang is currently in the planning stages of a mass timber building for the University of Stellenbosch as part of a new innovation district campus, Klopmitz, that is called Stellenbosch Bridge, and we're quite excited about this opportunity, hoping that it would come into fruition. There are obviously also various overseas case studies that can be studied, like this student accommodation example in Australia, fully CLT, but the external clad with aluminium. And overseas, various tower blocks are being planned right now, like the one on the left that is called the Dutch Mountains Project. And on the right, the Sara Cultural Center in Sweden that is already built. There's no shortage of examples. In Iceland, this perimeter block modeled accommodation block residential development is underway and to be completed in 2026. Various older examples exist in the USA where lumber buildings is nothing new. So if a case study needs to include knowledge of how the building performs over time, you can look at American examples. So at a conceptual level, what does this material offer an architect? It creates a warm building that is inviting. It's modern. It addresses acoustics. It is sustainable, lightweight, innovative, and versatile, calming, and flexible. So from a design point of view, the architect's imagination can do wonderful things with this product. We, as I mentioned, are busy with this workshop building, as we call it. This is the interior of it. That is also banking on the idea or the concept that in terms of neuromorphic design, a natural environment for people to work in improves their output, as you can see on the diagram on the right. So it has been found that people working in an interior with wood and plant finishes performs better than one in a grey and concrete environment. The future development where CLT construction is heading is to also incorporate the principles of modular construction, so that more elements are pre-manufactured and installed inside modules before going onto site. In South Africa at the moment, with the building regulations hampering the process a little bit, there's an emphasis on cottage design or smaller structures. So these are examples of work we're doing for a farm in the Winelands, looking at options for visitor accommodation, cottages. This project is the Granger next to the 2010 World Cup Stadium in Greenpoint. It is a mixed-use development that we're underway, busy with. And the idea there is that on the upper levels, some of the floors be done in CLT, as going the whole hog and starting all the way from the ground. We don't think South Africa is there yet. This project, however, pushed the limits already. On the left-hand side there, you see the new Deloitte building in the V&A waterfront, where Arab designed these CLT facades spanning over 2 stories, and look, quite a successful outcome. So, in wrapping up then, we've looked at the history, the international context, advantages, how to learn, how to use it, sources, resources that's available to you. So from an architect's point of view, there's no real remaining reason not to get involved, and everybody is invited. Thank you very much.
Great. There we are. Thank you very much, Francois. It's It's always so great to learn something new. 1 year's of these technologies, but thank you so much for doing your homework and for sharing with us. Right, if you'd like to switch your video on, then we can take some questions that have come through. Francois, I don't know whether you can hear me. There we are. Great, thanks. The obvious question, I think that many have to ask has been posed by Ken Lever. Termite and borer requirements? Question mark. You did make mention of that it is a challenge. So where do we? Is it a challenge that's overcome? Francois, can you hear me?
Yeah, but
Francois,
the actual question I didn't get.
The actual question. Ken Lever refers to termite and borer requirements. In other words, insect protection against termites. Question mark.
Yeah. So the South African timber industry has for many years been using Tanalith as a product, which is a chromium arsenate based product. It's quite a dangerous product, and that is also why the University of Stellenbosch is looking at alternatives that are more environmentally friendly, and they are making progress with that. So very soon there will be alternatives, but for the moment it's CCA.
Okay, great. Then also just a question on the charring requirements for the different regions. In other words, is there a difference in, let's say, the protection that charring would provide in KwaZulu-Natal North Coast as compared to Gauteng or the Karoo? Any comment on that, Francois?
You mean, does the building burn faster where it's drier?
Yeah, that's presumably the question.
Well, the empirical standards that's being developed for this overseas works on worst case scenario. So if you put up your building in a wetter, more humid area, I guess you'll just be that much better off. But the standards are for worst case scenario, dry areas.
Okay, great. And guidelines, I would assume that the industry provides guidelines for the reaction generally to climatic variances. You made mention of work that World Architects are doing up in Pretoria, up in the bushveld. You have also peculiar, challenges with dry climate and UV protection for timber. So the question really is, are there sufficient guidelines to specifiers?
Yeah, the outer face of timber in South Africa generally has a UV problem. So it's not recommended to expose the timber to the sun, and some form of cladding is usually applied on the face of the building.
Okay.
So, and then generally also keep in mind that timber has a very good insulation property. So from a climatic point of view or air conditioning point of view, it makes a lot of sense to go for timber because you get a whole lot of insulation for a very light and thin product. So in your different climatic zones, that benefit can also be used to, to the mechanical engineer when he does his calculations has to take that into account.
Okay, great. Thank you, Vivian Hobbs. Thanks for your thank you. Then Jacqueline Leroux says that we're told that timber grown in South Africa is of inferior quality or standard because of the rapid growth. Is this still true? Would one need to import the timber, or is local timber used?
Yeah, local pine for that reason, is considered a softer wood, and that's why Stellenbosch is experimenting with eucalyptus as well. Eucalyptus is a harder wood, so, but at the moment the product being manufactured here in the Cape Town factory is all local wood.
Great.
The product, even if the wood is not a hard wood, the manufacturing process of the product enhances the strength of it because of the cross lamination. And different layer thicknesses are made up 3 to 6 and 9 layers, depending on where in the building it is located and what the MPa rating for the downward pressure has to be. So it's all calculated and worked back to the strength of the timber that is taken into account in the manufacturing process. So if the timber is softer, you just use a thicker panel.
Okay, great. Ken Lever wants to know where he can contact you, and I would assume that it's Osman Lang's office in Cape Town, or where are you, Francois?
Cape Town, yes.
Okay, great.
Welcome.
Okay, right. Colleagues, Vivian Hobbs, thanks for your question, and I just want to check whether there's we actually got so many questions now, we're going to run out of time, colleagues. I'd love to deal with the rest of these questions, but if we do so, we're going to have to cut the next presentation short. So if you excuse me, all interested colleagues, and I can't even mention your names, there's so many of them that have just come through. Francois, there's been a lot of interest. Can I just say, Francois is in Cape Town. Drop him an email if you need any of these questions specifically answered, and I'm sure that he can refer you to bodies that can answer if he can't answer the questions. Francois. As I said, I'd like to carry on with the questions, but I'm going to have to then cut this discussion short. Thank you once again very much, and to all of those of you who've posed questions, thank you for them. Right, then that brings us then to the next presentation, and it's my privilege to introduce you to Gerald Steyn. Dr. Gerald Steyn is a registered architect and part-time research professor currently involved with the Department of Building Science at the Tshwane University of Technology. He holds a PhD from the University of Pretoria and MArch and BArch degrees from the University of the Free State. He is an unapologetic Corbusian. He has written 9 peer-reviewed articles on Le Corbusier and presented his research on Le Corbusier's work at conferences in the USA, Australia, India, and Saudi Arabia. What a privilege it is to have you with us this afternoon, Gerald. We look forward with expectation to hearing what you have to share on Corbusian regionalism. So, Gerald, over to you.
Thank you very much, Eugene. Good afternoon, people. I just want to confirm with Corina that I'm on and everything is visible on your side.
Everything is visible. You can go ahead.
Okay, lovely stuff. Thank you very much. The title of my presentation is Le Corbusier's Regionalism. It's about the way Le Corbusier interpreted and implemented regionalism. The lessons learned are, however, generally relevant. My credentials. Corina asked me, I'm not a golfer, I ran a bit. These are the main headings. The presentation consists of 40 slides in total and will take no more than 20 minutes. Okay, 22 minutes after this interruption. We will always write about Le Corbusier, since he confronted design issues that are increasingly relevant today. Le Corbusier has been continuously attacked for his city planning, such as his plan Voisin for Paris in France. There he proposed that part of the historic city be demolished for his towers in a park. In 1927, he coined the phrase, "A house is a machine for living in." This statement has been misinterpreted ever since. His critics claim he proposed a sterile, robotic setting. But as Le Corbusier explained, I quote, "Baths, sun, hot water, cold water, warmth at will, conservation of food, hygiene, beauty in the sense of good proportion." That is what he had in mind. Le Corbusier was the undisputed leader of the modern movement in architecture and articulated the only cohesive theories for its implementation. These are the 5 points for a new architecture and the 4 compositional systems. But I'm sure many of you are wondering, how on earth am I going to connect Le Corbusier with regionalism? Let me explain. Writings on regionalism have been with us for a long time. However, the term critical regionalism was only first defined by Leanne Lefebvre and Alexander Tsounis in 1981, 16 years after Le Corbusier's death. The theme has been addressed in a number of important publications, a few of them even exclusively dedicated to critical regionalism. It must be emphasized that the elements of critical regionalism are not well understood. Somebody once wrote that critical regionalism is a theory many architects and their clients might approve of, if only they could remember how to define it. Dibido Francis Kere, born in Burkina Faso, is one of Africa's best-known architects. He is the 2022 laureate of architecture's highest honor, the Pritzker Architecture Prize. His definition of critical regionalism is straightforward. I'm going to read this with you. Critical regionalism is the use of innovative approaches to create an environmentally responsible, climatically sensitive, and culturally embedded building. So back to Le Corbusier. His fascination with aircraft and ocean liners are well known. But there is evidence that he had always been a regionalist. Some authors even suspect that his taut white cuboid houses of the 1920s were partly derived from the Greek Mediterranean vernacular, such as these houses in Mykonos behind the book. Le Corbusier started traveling extensively and sketching along the way in 1907 and never stopped. His most formative trip was in 1911 when he visited Prague, Vienna, Budapest, Turkey, Greece, and southern Italy, including Pompeii. Later in his career, he also visited North Africa, North and South America, as well as India. Here are his sketches of a village street in Algeria, this village street in Turkey, and a farmhouse in India, top right. Out of the many possibilities, I selected the following case studies. A compound on an agricultural estate in Cherchell, Algeria. Cluster housing at Lassenbaum near the French coast. And a new hospital in Venice, Italy. Since they were not built, they have not been subject to the same analysis as his built projects. They are probably also not well known to practicing architects and technologists. I must confess that my choices were rather opportunistic. I really like these projects. This is where they would have been located. Cherchell in Algeria, Lassenbaum on the French coast, and Venice in Italy. Okay, first case study, the farmstead in Algeria, which was part of France until 1962. Le Corbusier wrote, I quote, the problem was not to colonize, but to provide accommodation suitable to the climate and local conditions. Although the drawings are quite rough, it is clear that Le Corbusier developed the design in considerable detail. According to him, quote, the design was based on the interplay of spaces and solids and was intended to reduce the problem, as he put it, to the most fundamental forms of Mediterranean tradition. The section through the compound. Designed in 1942 during the Second World War, there were no specialized craftsmen and building materials were almost unobtainable. For those reasons, it was intended that the building should be constructed by local labor and that local stone should be used for columns and walls. The floors and partitions were to be of wood and vaulted roofs of hollow bricks, also locally made. The wooden end walls may vary between transparent and translucent panels according to need. The second case study number 2, is a housing estate as part of an envisaged project which would have included the Basilica of Mary Magdalene and a Pilgrim's Hotel. It would have been a formidable project. This is my sketch to try and understand the form of the units. Le Corbusier wrote, quote, the means employed were those at the disposal of people who desire to do something but have only the resources of the unfortunate. The basic structure would have been rammed earth within wooden shuttering. A comment that I find intriguing, and I quote Le Corbusier, life in these rammed earth buildings can have great dignity and regain for man in the machine age a sense of the fundamental human and natural resources. Well, we get the idea, even though the translation from French into English is a bit awkward. The third case study is a large hospital, 1,200 beds, designed for Venice in Italy. Le Corbusier's words, another quote, by means of the horizontal disposition of the hospital, Le Corbusier, he often referred to himself in the third person, has tried to avoid any influence upon the historical skyline of Venice. The hospital's functions were planned on 4 levels. This project has been described as one of Le Corbusier's strongest ideas. Here he respected the skyline of the city, conceiving the buildings as a series of low boxes matted together in a complex pattern of overlapping walkways, platforms and spaces extending over the water on piers. The total area was more than 5 hectares, of which approximately 60% was built-up functional space, 15% was circulation, while courtyards comprised 25% of the total. In 1985, Tsonis and Lefebvre wrote, I have to quote them, towards the end of his life, his Venice Hospital project reiterated the hopes and aspirations of the younger generation of the 1960s, who demanded a low-profile architecture capable of being integrated into the existing urban fabric. Now the final section. What can we learn from these projects? What informed the shape of the agricultural compound? The vernacular Algerian village is certainly a possibility. We just don't know because Le Corbusier never revealed such information. Somebody once said he was good at covering his tracks. But in spite of such vernacular and organic roots, he nevertheless applied what he called regulating lines with great care. The inspiration for the vaulted cellular forms of Lissenbaum is more complicated. An author suggested that the St. Baum project seems to be directly derived from the Gorfa, which is a vaulted structure, often in multi-stories, used for storing grain in Tunisia, on the other side of the Mediterranean. But again, the vault is also part of the vernacular of the Northern Mediterranean. Bernard Rudowski published his Architecture Without Architects in 1964, 16 years after Lissenbaum was designed. This is one of his photographs of the Greek seaside town of Santorini, showing many vaulted forms. Actually, Le Corbusier first used vaults on his Manol houses of 1919, intended for mass production. Could it be that the Manol vault was already inspired by his early Mediterranean travels? Well, perhaps. Le Corbusier wrote that the design, that's now of Lissenbaum, was in deference to the landscape, modulated and even expressive of the landscape. The planted roofs are a cue that Le Corbusier not only wanted to merge the buildings with the site, he wanted them to be the landscape as if pushed up from the land. I also analyzed the siting on the slope. We can similarly speculate about the deep narrow spaces. Were they derived from the Neolithic megaron, which later became the main living room in the Greek houses of antiquity, or were they intended to focus on a spectacular view like through a telescope, or were they simply derived from the typical Mediterranean vernacular? Whereas the paths are organic, the building layout is more formal, but only a proper analysis revealed the configuration. Le Corbusier was obsessed with proportions, specifically the golden section, and at Lissenbaum he applied it rigorously. This is my analysis. Golden sections everywhere. In 1947, while he was involved with the United Nations headquarters in New York, Le Corbusier argued in favor of vertical garden cities. So his carpet plan for the Venice hospital must have been a great surprise to his detractors. Although also in 1947, he wrote of Venice as follows. Today, Venice is still our teacher. Classified circulation, supremacy of the pedestrian, the human scale. With classified circulation, he probably meant hierarchy of circulation. His response to historic fabric is radically different from the way modernist buildings were conceptualized at that stage. Venice. The carpet pattern and the configuration of circulation and enclosed and open spaces were clearly very, very innovative. Or were they? Timgad was a Roman city in the mountains of North Africa, founded around 100 AD. Each of the hospital's modules was as big as 4 Roman city blocks. So we can only speculate about Roman colonial settlements as sources of inspiration. What is much clearer is that he modeled the intersections of circulation routes according to the pattern Camillo Sitte recommended in his book on city planning in 1889. This is my drawing to analyze the project. William Curtis, a well-known author, wrote in 1986, I quote again, Le Corbusier's detractors have never ceased to bicker about his supposed insensitivity to urban context, but both Venice Hospital and Lissenbaum were based on the reading of underlying typologies in existing towns in terms of both buildings and spaces between. Now let's go back to Francis Quere's definition and compare his elements of critical regionalism with what Le Corbusier did. Quere said critical regionalism is the use of innovative approaches to create buildings that are, firstly, environmentally responsible. Le Corbusier specified local materials and methods which resulted in low embedded energy. All three schemes sit lightly on the land, and the scale of the buildings responds to the built fabric. Secondly, climatically sensitive. He adapted existing patterns of openings and shading, also used courtyards to moderate the climate. And thirdly, I'm jumping ahead, culturally embedded buildings. Here we find that the small scale and density of the Mediterranean vernacular is emulated, and so are the narrow lanes and alleys, while courtyards serve as social spaces. Finally, Le Corbusier's carpet buildings introduced a new modernist paradigm. Instead of buildings in a park, we now have parks inside buildings. That paradigm influenced a generation of architects, practicing as well as academics. Let's summarize. Vernacular architecture is essentially a regionalist phenomenon. Postmodern copying can, under certain circumstances, create a sense of regional space. As far as my presentation is concerned, all decisions seem to be based on a calculated and determined effort to respond pragmatically to a wide range of relevant parameters and constraints. The context, the local vernacular, and previously developed concepts and typologies gave Le Corbusier a huge choice of alternatives. These he articulated to create perhaps the definitive abstract form of modern regionalism. In conclusion, in many of his designs, he also interpreted regional images artistically in a sculptural sense. But that is outside the scope of this presentation. Finally, after years of studying Le Corbusier and visiting many of his projects, including Chandigarh in India, I concluded that critical regionalism is essentially post-World War II Corbusian modernism by another name. Personally, I am continuously amazed at the subtlety and depth of his creativity. Please note the copyright restrictions. All the drawings except mine belong to the Le Corbusier Foundation in Paris. And with that, I thank you for the opportunity and for your attentiveness. Thank you.
All right, there we have it. Thank you very, very much, Gerald. No, I feel like someone who's just said grace at table. You know, the old prayer which says, "We thank you for providing for our body and for our soul." And I think with today's presentations, we've had the practical and the abstract, and the two go so well together. Thank you very, very much. Gerald, I just want to check here what questions, if any, have come in. Let's just get to the list here. Right. Nico van Tonder says thank you. Vivian Hopp says thanks. Gunther Wagner, okay, you had a sound query. Johan Pansegrou sê baie dankie, Gerald. Norman Greaves, thank you for the visual tour. Simon Never, wonderful. Ken Lever, thank you. very provocative. Amanda Kotze thanks you. Theo Kraus thanks you. Natalie Ekotos Tsepu says thank you. Pierre Lombard says thank you. You've answered all the questions, I'm afraid.
I appreciate
Gerald.
that very much.
Yeah, colleagues, you can add the compliments. The questions and printouts will be available to the two presenters. So I can carry on mentioning names: Pierre, Andy, Victor, Michelle, Ursula, Diedrich, Denas Pillay, Francois, Christina. I'm looking for a question. I just can't find a question now. Okay, I'm going to pose the question, Gerald.
No, listen, that's fine.
We spoke briefly about this earlier. You showed us how Le Corbusier's architecture changed from walls with smooth textures to rough materiality of stone and adobe. How do you think his architecture would have evolved if he had lived longer? Any thought on that?
Yeah, listen, Eugene, that's a good question. I think in first world situations, he would have gone high tech, like Norman Foster and Richard Rogers. And in third world situations, or developing areas, he would have gone this rough regionalism. And I want to make a point there to substantiate that. This Lassenbaum scheme that I spoke about, that was now in rammed earth. Can you believe it? And a couple of 100 kilometers up the coast, he did exactly the same design, but in aluminium frame and metal infill panels. Exactly the same. You have to look closely to see that it's different. Same design, very close together. One totally regionalist with rough local materials, and the other one with materials transported in from a factory. That's why I think he would have gone those two ways simultaneously.
Okay, great, Gerald. Thank you. South African architects, can we apply similar regionalist approaches?
Yeah, yes, but I'm not going to single out any living ones. I mean, I've got friends in this audience, and they might really blame me if I don't mention them, because I try so hard. But the great legends, Harvey Fagan and Eaton, I mean, they followed exactly the same pragmatic route that Le Corbusier did. Not a tick box approach, a holistic, somewhat intuitive, creative approach, I think.
Okay, great. Let's just see whether any other questions have. Roger, thank you for your comment. George, really interesting presentation. Would you perhaps give us your view on the essential difference between regionalism and critical regionalism? Any comment on that, Gerald?
Listen, there are books and books and many opinions on that. And I think the term critical regionalism is an unfortunate one. I think Tsonus and everybody else, especially Tsonus, who I admire very much, should have simply called it modernist regionalism, because regionalism can, when we don't add the word, the term, the prefix critical, it can be lend over to vernacular. So I would say pure regionalism could range between vernacular, like what Hassan Fathi did in Egypt, to critical regionalism, which, like I said, is an unfortunate term. It should have been modernist regionalism.
Okay, Gerald, Ken just wants to know applicability to us in South Africa, and he refers to how, low income housing, how architects how can architects become much more involved in this failed and failing aspect of the built environment? It's a broad question. Any comment there?
Please repeat that,
Okay.
Eugene.
Ken just made the comment, the applicability to us in South Africa, especially the big question of low income housing, and how do professional architects become much more involved in this failed and failing aspect of our built environment?
Yeah, listen, that is a complicated question. The point is that rough stone and adobe is not going to work in low cost housing, because my experience is that it is immediately rejected as inferior. You know, it is people, more wealthy people, traveled people, they can live easily in an adobe house, for example. But I don't want to say anything more than that. But remember, if you design a low income house and it is climatically appropriate, then you're already getting there. And also, if you consider the way the house is being used by the people, like I know Tswana people like to wash their hands before they eat. So a cultural response would be to have a hand wash basin in or near the dining room. Those are regionalist concepts.
Okay, great. Christo, Hick Ruud, his compliments. And Ivona says, great creations with wood and concrete. Thank you for the presenters. Derek Libber, will it be possible to give a lecture focusing on Le Corbusier modular? Okay, we'll consider that going forward. Diederik, thank you. Then Stefan Antoni says, taking his references too literally results in period pieces. Are there architects who are interpreting his work appropriately? A question to you, Gerald, from Stefan. Taking his references too literally results in period pieces. Are there architects who are interpreting his work appropriately?
Does Stefan mean interpreting Le Corbusier's work?
I would assume so, yeah.
That is not the right approach to follow in any case. But you know, he's remember a few years ago at the Sophia Gray lecture, Andrew Macon said hardly any building higher than 2 or 3 stories in South Africa is being built without Le Corbusier's 5 principles. And that is where I think we should stay, within that framework, not looking at his specific buildings.
Okay, and then Patrick, Le Corbusier's Le Modular vertical scale, was this approach the same in these projects? Gerald, I don't know whether you understand that comment.
Yes, especially from in his projects after the Second World War, he applied his modular religiously, and the schemes, the last 2 schemes are totally based on the modular.
Okay, all right. Just a quick one from Gerrit Jordan. Gerald, do you think that Barrigan in Mexico also had the same approach?
Yes.
Okay, great.
Absolutely.
Right. Yes. Can we get a link to this presentation? Yes, colleagues, you can get a link to every SAIAshare presentation. It's published and then made available on the SAIA website as well as ECPD websites. So Thank you, Garius, for your comment. Thank you, Paul, for your comments. We'll try our best. Thanks for interesting presentations. Colleagues, thank you very, very much. I think that's where we're going to end. Please don't leave. We just have another minute or two of your time. So we come to the end of SAIAshare number 16. Thank you very much once again, Francois and Gerald, on behalf of everyone who's attended, for your most engaging presentations, both of them. Thank you to all of you who attended. We trust you have enjoyed the afternoon. By all accounts, you have. Your attendance and feedback makes the effort worthwhile. So please, if you can, carry on supporting us. SAIAshare carries a category 1 CPD value of 0.1. So 10 events gives you the value of 1 CPD point for the year. You will receive an email from SAIA within the next week or two for you to download your CPD certificates. Right, that brings us then to the program for next Friday. Not next Friday, for the first Friday of October. We do have as our first presenter, Chris Pearson. Chris has been in the professional indemnity insurance industry for many years. He founded SAIA's Apegist Architects PI scheme with the late Ronald Remmers. His topic is liability hazards. Architects have to deal with and risk mitigation actions. Please join us for hands-on practical advice from Chris. Then our second presenter, an exciting one, will be Gerard Bosman. He's an architect with 1 foot in practice and 1 in academia. And you've just seen from Gerald's presentation what that offers. Don't miss his exciting, colorful presentation called Water, Vapor, Ice, the traveling architect's own voice. Right, I'm going to leave you with just another quote from Charlie McKeesy's delightful book, The Boy, the Mole, the Fox and the Horse. And we can probably replace the word moles on the screen with the word architects. Most of the old moles I know wish they had listened less to their fears and more to their dreams. Colleagues, we invite you to join us on Friday afternoon, 7 October 2022 at 2:30 p.m. We wish you a pleasant weekend. Thank you.